We approach the problem of domain adaptation, where we consider transferring knowledge from models trained on a large labeled dataset, such as ImageNet or product images, to an unlabeled or sparsely labeled test dataset, such as images taken with a personal camera. However, because of differences between the two domains, in practice, simply training on the source domain, then testing on the target domain, results in degraded performance. To combat this, we learn a representation that mitigates domain shift in two ways. First, we maximize domain confusion by directly optimizing our representation such that a domain classifier is unable to identify which domain each image originates from. Second, we transfer task correlation between the two domains. We average the classifier activations for all source instances of a given category, then use that average to adjust the class activations when training on target data from the same category. Our method is implemented as a standard classification network with two additional loss functions, and allows us to learn a representation that achieves state-of-the-art classification on benchmark domain adaptation datasets in both supervised and semi-supervised settings.
Ferns ensembles provide highly accurate classification performance, which is adequate for many real-time applications, however, usually at the expense of a large memory footprint. Our proposal provides large memory reductions without decreasing speed or accuracy. In a typical image recognition task, the Fern ensemble can accurately classify a large number of samples per millisecond. The number of parameters that should be kept in memory typically grow exponentially with the classification performance. We detect parameters that are non-essential for the classification accuracy, maximizing valid classifying responses regularized with the number of non-zero parameters. This sets to zero most parameters in the model. The remaining ones are stored in a sparse container. We also reduce the memory size for each parameter by decreasing its precision. Overall, we obtain large memory reductions, eliminating one of the main disadvantages of Ferns ensembles. Meanwhile, our proposals ensure to retain a high classification speed and accuracy.
In traditional classification tasks, both training and testing data are assumed to exhibit similar distributions. However, if such data are collected from different domains and result in distinct data distributions, unsupervised domain adaptation will be required to solve this problem. In practice, the training data in the source domain may be collected from multiple subsets. Moreover, the label numbers across domains might not match. Therefore, most existing UDA methods cannot be directly applied to solve such problems. To address these two types of problems, we propose closest common space learning, which integrates embedding projection and latent domain discovery for deriving a common feature space for UDA. This feature space is learned by the minimization of J, which updates the solution for each component in each iteration. Our experiments on the Office and Caltech datasets show that compared to recent UDA approaches, our method produced promising results on mixed domain and imbalanced UDA problems. In addition, T-SNE embedding graphs also confirmed that our CCSL was able to improve data separation in the derived feature space for UDA.
This paper tackles the problem of multi-label learning with missing labels. It is a common problem in real applications like image annotation. We propose the use of 3 types of prior knowledge to handle missing labels. The first 2 focus on instance similarity and class co-occurrence. They are formulated as an unweighted graph, allowing label information to propagate between instances. Moreover, we use semantic hierarchy between classes and embed it as directed edges in the graph. This hierarchy also guides label propagation by enforcing that a parent class exists if its child does. Semantic hierarchies are constructed from WordNet. We formulate the overall binary problem as a submodular constraint optimization, which is further relaxed to a convex problem. We apply our approach to several annotation benchmarks and show that it leads to substantial improvements over state-of-the-art. Here are some qualitative image annotation results. For more details, please stop by our poster.
We present Speedo, a novel ego motion sensor that measures its own motion without requiring any external devices. Speedo can precisely measure small motions in 6 degrees of freedom, even from textureless flat surfaces. Other camera-based methods, such as SLAM, do not have this functionality. Speedo is based on using coherent light sources and cameras with large defocus. Coherent light, when interacting with a scene, creates a high-frequency interferometric pattern in the captured images. This is called speckle. We develop a theoretical model for speckle flow and show that it is possible to recover the full 6 degrees of freedom by using speckle flow from 2 co-located cameras focused at different depths. These videos show the speckle flow with different focus positions. Even when the camera trajectories are identical, the measured focus is completely different.
In this work, we are interested in multiple target tracking by min-cost flow data association. We propose an optimal algorithm for online scenarios and an approximation for real-time applications. Given a set of detections per frame, our goal is to find the optimal set of trajectories subject to unary and pairwise constraints. Detections are ordered in time to form a graph. The optimal set of trajectories is found as the set of shortest paths between the source and target nodes. While existing approaches capture only batch settings, our algorithm can be extended to the online setting. Our main contribution is an efficient, near-optimal approximation for real-time scenarios. This video compares our approximate real-time solution at the bottom to the original batch algorithm on the top.
Our work takes as input unsynchronized videos capturing the same dynamic objects. The method reconstructs sparse 3D points of the dynamic objects. The main challenge is that the videos are unsynchronized and it can have different frame rates. Our method uses the observation that a 3D shape can be well represented by linear combinations of a few spatiotemporally close shapes. The coefficients of the linear combination are computed through compressive sensing. In our method, we propose to optimize over both the 3D structure and sparse coefficients alternatively. Here, we show the reconstructed results from different perspectives.
C'est excessivement relou de faire ce genre de truc.
This paper addressed the problem of learning feature for video understanding. Given some input videos, the algorithm predicts what object and scene action are happening in the video. Recent approaches adapt 2D convolution network to video. However, 2D convolution collapse temporal information very fast. Thus, it's not suitable for motion modeling. Here, the main difference between 2D and 3D convolution. 2D convolution handle motion modeling. 2D convolution applying on multiple frames collapse temporal information after one convolution. 3D convolution preserve the temporal information, thus better for motion modeling. To learn video feature, we train a deep 3D convolution network on spot 1 million dataset using our CTD architecture. Our learned feature have the desired property for large-scale application. It's a highly accurate and very simple to use. It's very compact and efficient to extract. Our retrained model are also available in the project website.
Egocentric videos are a valuable source of information as a daily log of our lives. In this paper, we propose a new storyline representation that epitomizes an unconstrained egocentric video using a set of jointly inferred story elements. We define actors as friends or family members who interact with the subject, events as various common activities in which visitors can participate, locations as attraction-based localization obtained from the Disneyland maps and guides. Through unsupervised learning, we discover supporting objects. By leveraging our model of story elements, we can perform story-based retrieval that allows users to easily review locations and events and find objects or people of interest. We use and/or graphs to encode user queries. For more details, please stop by our poster.
A common problem in computer vision is how to represent a set of features efficiently and informatively. A state-of-the-art method is covariance matrix. A set of d-dimensional features are represented as a d by d covariance matrix C. Cij is the linear correlation between S and J's features. It's just a linear kernel function. Issues: C is singular if feature dimension d is high, and only linear correlation is estimated. Instead, we propose to use the kernel matrix. Advantages: nonlinear relationship can be modeled. M is guaranteed to be non-singular for many kernels, and the size and efficiency of covariance is maintained. Significant improvement has been observed in applications of skeleton-based action recognition, image set, and object classification.
Hi, I am Mihir and this is a joint work with Jan, Thomas and Case. Our objective is to recognize actions in videos without using any video example. Instead, we use images and object class labels. This is done using proposed objects to action, a semantic word embedding space spanned by thousands of object class labels. Our setup is a bit different from the conventional zero-shot setup. We use images as training samples and object labels as training classes to predict action class for a given video. We build a semantic link between object and action class labels by semantically embedding the labels and computing object-action affinities. Using a word-to-vec model trained on the metadata from Flickr images, we first compute word vectors. Then using GMM learned from 15,000 object labels, we compute Fisher word vectors as our semantic embedding. Finally, we experimentally show that our approach is relevant to several zero-shot tasks. Thank you.
Here's an example of video entity linking on the recent movie Imitation Game. Current system is limited on celebrities. Our paper studied the challenges extending it to general entities. Given the video metadata, we link the text to entities. Given entity candidates, we search related images. We match the video with the image set, and we verify entity candidates using learned metrics. Training data are the keyframes, the image set, and the label. The label tells whether they are matched. We employ AMT to collect these labels. The challenge is that for all the pairs between two matched sets, only some of them are true match. We approach this problem using multiple instance metric learning. The algorithms alternatively infers true matched pairs and adjusts parameters. Another challenge is the overwhelming noise in the dataset. To suppress noise, we propose structural constraints.
In this work, we address a new partial person re-identification problem, where only a partial observation of a person is available for matching across different non-overlapping camera views. To solve this problem, we propose a framework consisting of a local-to-local matching model based on a novel sparse representation classification formulation with explicit patch ambiguity modeling, and a global-to-local matching model providing complementary spatial layout information. Our framework is evaluated on a new partial person re-identification dataset, as well as two existing datasets modified to include partial person images. The results show that the proposed model outperforms significantly existing re-identification methods, as well as other partial visual matching methods.